Hi, everybody. It's Mr. Clegg. Welcome to another physics lesson. Today, we're going to study finding the net force. How do we add force vectors together? And we're going to be doing this in two different situations. By the end of this lecture video, you'll be able to add forces when the forces are in the same direction or when the forces are in the opposite direction. So let's get started. Okay. When the forces are in the same direction, we add up the values and the net force is in the same direction. So here we have an example. These two folks are pushing on a big box, and this person is pushing with a force of 100 newtons to the right. This other person is pushing with a force of 80 newtons to the right. So if we want to find the net force, they're both pushing in the same direction. So we're just going to add up those two forces together. And what we find is that we have, I can do that in my head, we have 180 newtons. And so we're going to indicate the direction of the net force with a orange force vector here. We're going to say that the net force, and I'm going to write F net equals 180 newtons. Whoa, there we go. 180 newtons. Now I could either write a force vector like that, or I could write the words, but you have to do one or the other. You could say to the right. All right, so you could either use words or an arrow to show the direction, but you have to do one or the other. All right, and when the forces are in the opposite directions, we subtract the values, and the net force is in the direction of the larger force. So now we have these two folks that are now trying to pull on this triangular shaped object. This person is pulling with 100 newtons to the left, and this person is pulling on the rope with 80 newtons to the right. So since they're opposing each other, we are going to subtract those forces. All right, so we're going to take 100 minus 80, and that's 20. Okay, so we have 20 newtons. I'm going to write F net equals 20 newtons. But the question is, which direction is it? Well, the net force is in the direction of the larger force. So in this case, the net force is going to be to the left because the bigger force is over here. So the net force isn't very big, it's only 20, but it's going to the left. And you can sort of think of it like this. Let's say you walked 10 steps to the left, and then you walked 8 steps to the right. Wouldn't you be 2 steps to the left? Or if you walked 100 steps to the left and 80 steps to the right, you'd be 20 steps to the left of where you started. So that's a way you can think about adding these vectors. All right, we're going to do 2 more examples. So here's an example, the Lunar Lander. So this Lunar Lander is in the process of landing on the moon right at this moment. And gravity from the moon is pulling it down with a force of 8,900 newtons. And the thruster is firing right now, and it's not firing very hard because it's only giving an upward thrust of 7,250 newtons. Now, some of you might be wondering, well, wait a second, how come the thrust is in the upward direction when the thrust, like the thrusters are firing downward, right? And that has to do with Newton's third law, and I'm not going to go into it, but just briefly, for every action, there's an equal and opposite reaction. So what's happening is the Lunar Lander is spewing all sorts of burning gases out the bottom here. And the result of that is that there's a force upward on the object. It's kind of like when you want to go forward, you have to push the ground backward. If I wanted to swim forward, I would push backward on the water. If I wanted to, let's say I was on a skateboard and I wanted to go forward, I would push the wall backward. So you have to push the opposite way that you're going to go. Basically, that's the idea. All right, so hopefully that's not confusing that the flames are coming out the bottom, but the force is up. Okay, just wanted to clarify that. So how are we going to find it? Well, we're going to have to subtract these. And so we're going to subtract we're going to start with the bigger number and subtract the smaller number. So that the net force is going to be, let's see here. The net force is going to be 8,900 newtons minus 7,250 newtons. And I'm just going to use my calculator because I don't really need to do arithmetic here. So 8,900 minus, did I copy that right? 7,250. All right. And what do I get? I get a result of 1,650. So the direction is 1,650. I mean, that's the magnitude, sorry. And which is the direction? The direction is down because this is the bigger force. So here I have my net force. And I probably want to draw it a little shorter than that to be proportional to the others. There we go. So this is 1,650 newtons in the downward direction. Okay, I'll put equals there. And now we're going to have one more example. We have a toy boat. So this child is pulling the boat, and it also has a motor that is running because it's a toy boat. And so there are two different forces, and they're both going in the same direction. So the child is pulling with a tension of 3 newtons, and the thrust from the motor is 2 newtons. So the net force, see if you can figure this out before I say it. Just pause the video and see if you can get it. Okay. Now, the net force is going to be the sum of these two. 3 and 2 is 5, so it's going to be 5 newtons. And the direction is in the same direction as these others. And so I'm going to draw a longer arrow because it is proportional to these arrows that we have here. So there's our net force is in that direction, same direction as the others. Okay, let's just wrap this up here. Let's review. When we're adding forces that are in the same direction, we add them. And the net force is in the same direction as well. Okay, so that one's simple. When we're adding forces in opposite directions, we subtract them. The net force is in the direction of the larger force. All right, I hope that makes sense. Good luck, everybody. See you later.